In 1972, deep within the heavily fortified walls of the Pirlat nuclear enrichment facility in France, a chilling discovery brought the entire operation to a grinding halt. Analysts running routine mass spectrometry tests on a recent shipment of uranium ore stumbled upon a mathematical impossibility. The ore had been extracted from the Oklo mine, situated in the dense, suffocating jungles of Gabon, Africa. According to the fundamental laws of physics, every single deposit of natural uranium on Earth, on the Moon, and even in meteorites striking our planet, contains exactly 0.720% of the highly radioactive isotope uranium-235. This isotopic ratio is a universal constant, forged in the hearts of dying stars and scattered across the cosmos. But the samples from Oklo did not conform to the rules of the universe. They registered at 0.717%. While a deviation of 0.003% might sound insignificant to a layman in the realm of nuclear physics, it is a catastrophic anomaly. It meant that something, or someone, had altered the atomic signature of the rock. As the French Atomic Energy Commission dug deeper into the geological data, the horrifying scale of the discrepancy emerged. Across the entire Oklo deposit, a staggering 200 kilograms of uranium-235 had simply vanished without a trace. This was not a rounding error. 200 kilograms of weapon-grade material is enough to construct at least half a dozen devastating nuclear warheads. Panic immediately swept through the international intelligence community. The height of the Cold War was looming, and the terrifying prospect of a clandestine nuclear weapons program or a massive terrorist theft became the primary focus of international agencies. Global security protocols were triggered. Investigators were dispatched to the sweltering depths of the African mine, expecting to find evidence of sabotage, secret extraction facilities, or a highly sophisticated smuggling ring. However, what they found buried beneath the ancient African soil shattered everything we thought we knew about the history of our planet. There was no theft. There were no secret agents. The missing uranium had not been stolen in the modern era. It had been consumed, burned away in the fiery core of a fully functional, highly regulated nuclear reactor. But the most terrifying detail was the age of the surrounding rock. Geological dating mechanisms returned a number that left scientists in a state of absolute disbelief. The reactor had been active exactly 2 billion years ago, long before the first dinosaurs walked the Earth, long before a single blade of grass had grown, and billions of years before humanity even existed to split the atom. A nuclear engine was humming in the dark. To comprehend the sheer absurdity of this discovery, one must understand what it actually takes to build a nuclear reactor. It is the pinnacle of human engineering. It requires thousands of brilliant minds, decades of theoretical physics, supercomputers, and materials refined to an almost impossible degree of purity. It is not something that just happens by accident. Yet, mainstream science asks us to believe that nature, blind and random, somehow managed to assemble a flawless atomic engine. Let us look at the mathematical nightmare that Oklo presents to modern geologists. For a nuclear fission reaction to become self-sustaining, several highly specific, almost contradictory conditions must be met simultaneously. First, the concentration of uranium-235 must be at least 3%. Today, natural uranium is far too diluted to sustain a reaction. But 2 billion years ago, due to the different decay rates of uranium isotopes, the natural concentration of uranium-235 on Earth was exactly 3%. This is the precise enrichment level used in the cores of most modern pressurized water reactors today. It was as if the fuel had been perfectly prepared and waiting. But fuel alone is not enough. A nuclear reaction releases neutrons at incredible speeds. If these neutrons are not slowed down, they will simply bounce off other uranium atoms without splitting them, and the reaction will instantly die. To slow them down, you need a moderator. Human engineers use heavy water or hyper-pure graphite. At Oklo, the moderator was water, but not just any water. It had to be groundwater of absolute purity, devoid of any dissolved minerals that could absorb neutrons. A single drop of contamination containing elements like boron or lithium would have acted like a poison, absorbing the neutrons and killing the chain reaction immediately. Somehow, the geological formation at Oklo created a perfect, hermetically sealed filtration system that delivered only the purest water into the reaction chamber. And the physical geometry of the ore veins defies all natural logic. The uranium deposits were not scattered randomly. They were concentrated in distinct lens-shaped pockets, exactly half a meter thick. If the veins were slightly thinner, the neutrons would escape and the reactor would not start. If they were slightly thicker, the reaction would run out of control, leading to a catastrophic meltdown that would have vaporized the entire region. The spatial dimensions of the Oklo deposits were arranged with the terrifying precision of an architectural blueprint. Geologists have spent decades trying to formulate mathematical models to explain how tectonic shifts and underground water currents could randomly sort heavy metals into a perfectly optimized nuclear core. Every model falls short. The scientific community remains paralyzed, forced to label Oklo a freak of nature, a miraculous geological coincidence. Because the alternative, the idea that something intentionally designed this structure, is too terrifying to acknowledge. Consider the location itself. The Oklo mine sits on a very specific tectonic fault line, one that has remained shockingly stable for over 2 billion years. In a world characterized by violent continental drift, massive volcanic eruptions, and crustal recycling, this specific patch of land in Gabon acted as a pristine, undisturbed vault. It is as if the site was carefully chosen for its long-term geological stability. Furthermore, physicists studying the site discovered traces of xenon gas, a highly volatile byproduct of nuclear fission trapped perfectly within the crystalline structure of the surrounding rock. Xenon is an inert gas that should have easily escaped into the atmosphere over the span of 2 billion years. Yet, the rock surrounding the Oklo reactor acted as an impenetrable containment vessel, holding the radioactive signatures locked away, like a time capsule waiting to be opened. The deeper we dig into the physics of Oklo, the more the illusion of a natural occurrence falls apart. We are looking at a system that displays all the hallmarks of conscious engineering, disguised beneath billions of years of geological dust. But the most astonishing feature of the Oklo reactor is not how it started, but how it managed to survive without destroying itself. When a modern nuclear facility loses its cooling system, the results are catastrophic. We have seen the horrific consequences of runaway nuclear reactions at Chernobyl and Fukushima. A core left unmonitored will relentlessly heat up, eventually melting through its containment vessels and triggering a massive steam explosion that contaminates the atmosphere for generations. So, how did a reactor buried in the African jungle operate for 100,000 years without a single catastrophic meltdown? The answer lies in a thermodynamic fail-safe mechanism, so elegant and flawlessly executed that modern engineers are still trying to replicate it. Physicists mapping the xenon isotopes trapped in the rocks discovered a rhythmic, pulsing operational cycle. The reactor essentially breathed. Groundwater would seep into the uranium-rich pockets, acting as the moderator to slow down the neutrons and initiate the nuclear chain reaction. As the uranium atoms split, they generated colossal amounts of heat. The temperature inside the subterranean chamber would rapidly spike, boiling the groundwater. Within 30 minutes, the water would completely vaporize into steam and escape through microscopic fissures in the surrounding rock. With the water gone, there was nothing left to slow the neutrons down. The nuclear chain reaction would immediately stall, effectively hitting an automatic kill switch. The reactor would then sit dormant, slowly cooling down in the dark over a period of exactly 2.5 hours. As the temperature dropped, groundwater would once again gradually seep back into the chamber, filling the voids, and the entire nuclear cycle would restart. 30 minutes of intense atomic fire, followed by 2.5 hours of silent cooling. This incredibly precise geyser-like mechanism acted as an eternal, unbreakable thermostat. It prevented the core from ever reaching the critical temperature required for a meltdown. Imagine the Earth 2 billion years ago. The atmosphere was a toxic soup of methane and ammonia. The continents were barren expanses of rock, devoid of any complex life forms. The oceans held nothing but microscopic single-celled organisms. Yet far beneath the desolate surface, a colossal machine was humming. A rhythmic heartbeat of atomic power, perfectly balanced, managing highly dangerous radioactive waste with an efficiency that shames our 21st century technology. At Oklo, dangerous radioactive byproducts like cesium and barium were not allowed to leak into the surrounding environment. They were chemically bound and permanently entombed within a matrix of ruthenium compounds, safely locked away from the biosphere for billions of years. This brings us to a terrifying crossroads in our understanding of history. The scientific establishment demands that we accept Oklo as a freak accident of nature, a bizarre statistical anomaly where underground water and uranium ore just happen to collide in the exact proportions required to mimic a highly advanced technological facility. But when you look at the sheer weight of the evidence, the flawless uranium concentration, the hermetic containment, the rhythmic cooling cycle, and the permanent waste disposal, the natural hypothesis begins to look like a desperate attempt to maintain our comfortable worldview. Humanity suffers from an extreme case of chronological arrogance. We firmly believe that we are the absolute pinnacle of evolution, the first and only species on this planet capable of manipulating the fundamental forces of the universe. But 2 billion years is an unfathomably long time. It is a vast, dark abyss of forgotten history. If a highly advanced, technologically superior civilization had existed on Earth 2 billion years ago, what evidence would they have left behind? The harsh reality of planetary geology is that time erodes everything. Every skyscraper of steel and glass, every sprawling concrete metropolis, every bridge and every monument would be ground into microscopic dust within a few million years. The relentless grinding of tectonic plates, the endless cycles of glaciation, and the acidic erosion of the elements would wipe the surface of the Earth completely clean. Nothing physical could survive that kind of temporal abyss. The only footprint that could possibly endure for billions of years would not be found in fossils or architecture. It would be found at the subatomic level. It would be an unnatural isotopic signature permanently burned into the bedrock of the planet. What if the history of Earth is not a straight line of progressive evolution, but a terrifying cycle of rise and catastrophic fall? Every time a civilization reaches the nuclear threshold, they inevitably reset the clock. Perhaps the missing uranium from Gabon was not an accident of nature. Perhaps Oklo is the final fading echo of a civilization that rose to unimaginable heights, mastered the power of the atom, and was subsequently wiped from the face of the Earth by the relentless march of time or their own destructive hubris. They left no statues, no written records, and no bones. They left only an impossibly perfect atomic engine, buried in the dark, waiting for another civilization smart enough to understand what they were looking at. Are we truly the first to split the atom? Or are we just the latest species to stumble upon a power we barely understand? The universe is vast, and the history of our planet is filled with shadows we have yet to illuminate. Do not forget to subscribe to the channel, hit the notification bell, and leave a comment below with your thoughts on what really built the ancient reactor of Oklo.